Bring up the homework. Okay. So here's we're doing sections 3.1 and 3.2. So let's get right into it. Section 3.1 first. Let me go back to 3.1. There we go. And I always start at number 1. So here's the first question. Determine whether the statement is true or false. You're taking a test that has true or false and multiple choice questions. And the event is choosing false on a true or false question, and then choosing A or B on the multiple choice question is a simple event. So we have two things going on here. Choosing false and choosing A or B definitely has more than one outcome. Okay, so this definitely is not simple. Okay. It requires the probability of, so we're looking at not A, not B. We have too many things going on. It can be simple. Okay, so the event is not simple because it requires probability of the true or false questions and the probability of multiple choice questions to be calculated. No, false because it consists of two possible outcomes. Okay, A or B. Okay, that's the deal breaker. So I'm going to do D. Okay. Next question. Let's do number, how many questions do we have? 14. Let's do number 4. So, determine the number of outcomes in an event. Decide whether the event is a simple event or not. Okay, so you randomly select one card from a standard deck of 52 playing cards. Event C is selecting a red card. Now, red card, it can be any one of the 26 red cards, right? There are 26 red, 26 black. So event C has how many outcomes? 26. All right. Hope everybody understands that there are 26 red cards. Okay. The hearts and the diamonds are red. So 26 outcomes. Next question. Is the event a simple event? It can't possibly be. Way too many possibilities. So no, because event C has way more than one outcome. All right. So next question, let's do number 7. All right, 7 says, classify the following statements as an example of classical probability, empirical probability, or subjective. Okay, let's remind everybody what each one is. So classical, this is theoretical. Okay, empirical, this is data supported. And subjective, this is a wild guess. Okay, let's see this first one. So probability of choosing 5 numbers from 1 to 46 that match 5 numbers drawn by a certain lottery. Okay, so whenever we are at the mercy of a game of chance, it is usually a classical probability. All right, that's my guess. Since okay, so once again, we're trying to pick 5 numbers, playing the lotto. Every combination of 5 numbers has equal chance of being drawn. I like that one. Let's see if I'm right. All right. Okay. Let's do number 10. So number 10 says the access code for garage door consists of 3 digits. Each digit can be any number from 0 through 8, and each digit can be repeated. All right. So 3 digits. Okay, so let's draw a picture. Now, be careful though. How many numbers are there from 0 through 8? And here's a clue, not 8. Okay, if you count 0, count using your finger, 0, 1, 2, 3, 4, 5, 6, 7, 8. So they're actually 9. Yep, Brittany, you're right. Okay, thank you, Azetta. So 9, 9, and 9. Okay, so what's the probability of random selecting the correct access code on the first try? So we're trying to guess the code. Well, actually, what's more in a second? Okay, so this would be 9 times 9 times 9. We want to find out how many codes are there altogether. Okay, and then determine. Okay, thank you, Whitney. 729. I appreciate the help. Okay, so now we're gonna do 1 out of 729. Okay, so if I have to calculate that, see if I can beat you guys to it. Okay, so 1 divided by 729. And how many digits do they want? They want 3 decimal places. So 3 decimal places would be 0.001, right? So 0.001. That's 3 decimal places. Okay. All right. Next, what is the probability of not selecting the correct access code on the first try? Okay, well, that's a very good chance of not guessing it right. But as a matter of fact, not getting it, okay, so not is the keyword here. Let me do it better. So in probability, you're always looking for the keyword. The keyword here is not. And when you see not, you do the 1 minus. 1 minus 0.001 would be 0.999. All right, so let's do 0.999. Let's check it. Okay, all right. And we'll wrap it up with the last one, number 14. So you guys can't say that I only do the easy ones. Okay, number 14. In gambling, the chance of winning are often written in terms of odds rather than probabilities. The odds of winning is the ratio of the number of successful outcomes to number of unsuccessful outcomes. All right. So this means, for example, the odds of losing is the ratio of number of unsuccessful outcomes to the number of successful outcomes. So for example, if the number of successful outcomes is 2 and number of unsuccessful outcomes is 3, so let's say, you are drawing one of 5 numbers, okay, and 2 are winning numbers, the other 3 are losing numbers, okay, then your odds of winning would be 2 to 3. Okay, so if you ever wonder what that means, if you ever watch sports, they give you the betting line, okay, or whatever, okay, then that means there are actually 5 possibilities, okay, and 2 of them are winning, and 3 out of 5 are losing. Okay. All right. So the odds of an event occurring are 3 to 4. Okay, so now we're looking at the different events. Okay, 3 to 4. So find the probability that the event will occur and the probability of the event that will not occur. Okay, so 3 is occurring. Okay, 4 is not. Okay, and the total possibilities would be 3 plus 4, which is 7. So 3 out of 7 is going to occur. 4 out of 7 not occur. All right. So it wants a decimal to 4 places, thousands. And no, 3 places. All right, so let's do that. So 3 divided by 7. Okay, 3 places would be 429. So 0.429. Let's check that. Okay. Next, they want will not occur, okay, which would be the other 4 out of 7, or you can do 1 minus. Either way works. Okay, so let's do that. So I'm going to do 4 divided by 7 would be 571. Okay, 0.571. Let's check that. Okay. Is that it? Oh, that's it. Okay, so that's section 3.1. So let's take a look at 3.2. All right, here's 3.2. We have 8 questions. Let's see how many of these can I do. I don't want to do too many. You know what I'm saying? I don't want to spoil it for you guys, right? I want you guys to have some fun with these. So let's do number 1. So number 1 says, the accompanying table shows the results of a survey in which 250 male and 250 female workers aged 25 to 64 were asked if they contribute to retirement savings plan at work. All right, so there's going to be a table. So let's look at the table. All right, so we have a table that are sorted 2 different ways. Okay, first is male, female, and the other is whether they contribute or not. All right. So first question, find the probability that a randomly selected worker contributes to a retirement savings plan at work. Okay, here's the key word or key phrase, given that the worker is male. So whenever you see the given, it automatically limits the people that you are looking at. We're only looking at male. Okay, we're not even looking at females. Okay, so we don't care about the females. Only in this example. All right. So out of the 250 male, okay, the ones who contributes to the retirement savings would be 114. So this would be probability of a person who contributes given that the person is male. Okay, when this is given, then that means, we're only looking at male. All right. So we're going to do that calculation here. And the calculation is going to be 114 divided by 250. All right. And I think it wants 3 decimal places. So let's click on equal. So 0.456. All right. Put it here. All right. So 0.456. All right. Next. So find the probability that a randomly selected worker is female given that the worker contributes to retirement savings plan at work. So given this. So now we're only looking at the people who contribute. Okay? We're only looking at this group. Don't care about those people. So what is the denominator? The total number of people who contributes is 269. Okay, so out of the 269, what is the chance of picking a female? There are 155 females, so the probability of a female given the people who contributes would be 155 out of 269. And Whitney gave me 0.576. Okay. All right, let's see. 0.576. So I assume that is 155 divided by 269 for anyone who's watching this as a recording and not sure what Whitney's doing. So let's check that. All right, so let's check that. All right, thank you. All right, thanks for the help. Okay, next question. All right, so let's cross that off, cross this off. Erase these. Okay, so now we're going to go to number 1, 3. I'm going to do 4 questions here, simply because some of these things are a little convoluted. Okay, I'm going to do 1, 3, 5, and 8. Okay, so I'm going to do 3. So number 3 says, a study found that people who suffer from obstructive sleep apnea are at increased risk of having heart disease. Identify the 2 events described in the study. Okay, so there are 2 events going on here. And what are they? So first event is suffer from sleep apnea. Second event will be having heart disease. All right. Do these results will indicate the events are independent or dependent? I think it's pretty obvious since one would increase the risk of the other. I'm going to say that it's dependent. Oh, identify the 2 events first. All right, so let's do that. So the 2 events are sleep apnea and heart disease. This that we see. Okay. Now the second part, are they independent or dependent? Since one is going to cause the other, dependent, or one would increase the risk of the other, I should say. All right. So that's it. Okay, so let's do 1, 3, 5, and 8. So let's do 5. No, let's do 6. I'm going to do 6. I'm going to increase the difficulty of this one. Okay, let's see. Number 6. Okay, number 6 says the probability that a person in the United States has B plus blood type is 7%. 5 unrelated people are selected at random. Complete parts A through D. All right. So first, what's the probability of all 5 B pluses? Okay, so all 5 would be 0.07 times 0.07 times 0.07 times 0.07 times 0.07. All right. Oh, 6 decimal places. Okay, let's see what that number would be. Points. There's my calculator. Here we go. So 0.07 times 0.07 times 0.07 times 0.07 times 0.07. Okay, I'm looking at 0.0000016807. So if I'm going to get 6 decimal places, it's going to be 0.000002. Let's check that. Okay. Next, find the probability that none of them have type B plus blood. Okay, so now we're going to go into not. So P, none of them. Now, none of them So now think about it. Okay, so what's the probability of the first person not having it? Okay, so first person not having it is, so not B plus would be 1 minus 0.07, right? So which is 0.93. So if I'm going to do 5 people, so 5 people not B plus would be 0.93 times 0.93 times 0.93 times 0.93 times 0.93. All right. Hopefully that makes sense to you. Okay. One person, not B plus, 0.93. 5 people, all not B pluses. I multiplied that number 5 times. Let's see if I'm right. I should be, but okay, 0.93 times 0.93 times 0.93 times 0.93 times 0.93 would be, okay, it's 3 decimal places, so 0.696. All right. All right, good job. Lastly, find the probability that at least one of the 5 has type B blood. So this kind of going back to the example that we did in class, right? Okay, so at least one that has that means that what's the probability? So 5 people, none of them has it, okay? But if at least one has it, so it would be the not this, right? Because 5 people not having B plus, okay, we just calculated that, which is 0.696. Okay, but if at least one of them has it, that would be the flip side of this, right? 5 people, none of them has it, okay, but at least one has it would be the flip side of this. So to calculate this would be 1 minus 0.696. So this is probability of not all non B pluses, okay, which is equal to 1 minus 0.696. All right. So that should be 1 minus 0.696 is 304. Thank you, Whitney. Okay, so let's see if that's all right. All right, good job. Lastly, which of the events can be considered unusual? Now, so look at all the different numbers, okay? Now, the unusual ones, once again, the rule, so rule of unusual is less than 0.05, okay? So I say that to get 5 people with B plus blood, it's unusual, all right? So that would be event in part A. Let's see if I'm right. All right. Okay. And let's do number 8. Okay, by rewriting the formula for the multiplication rule, you can write a formula for finding conditional probabilities. Okay, so if you remember, the formula for conditional probability is probability of A and B equals to probability of A times probability of B given A. All right, this is what we covered, although I didn't really write that formula out. explicitly. Okay, but that's how we got this formula here. Okay, so let's just see what they want. All right, so the question is asking, use the information below to find the probability that a flight departed on time given that it arrives on time. All right. Okay, so probability of airplane flight. So, okay, so let's define our A and B. Okay, what is A? So A is um A is departed on time. B is arrived on time. How do I know this? Okay, so here is, so find the probability that a flight departed on time given that it arrives on time. So the given has to be A, okay, because in the formula there's only one of the two events that's given, and we're looking at it, okay, given A. So arrives on time is A, okay. Departed on time would be B. All right. Okay, so let's see what they want. So the probability that an airplane flight departs on time is 0.89. So the probability of B is 0.89. Probability that a flight arrives on time is 0.87. So P of A is 0.87. And the probability that a flight departs and arrives. So now this is the P, A, and B is 0.82. All right, so P, A, and B is 0.82. Okay, so the question says the probability that a flight departed on time, given that it arrives on time. Okay, this would be the probability of B given A. Okay, using the formula that we're given in the question. So P of A and B divided by P of A, that would be 0.82 divided by 0.87. Okay, so we just need to calculate that, punch it in the calculator. Okay, so 0.82 divided by 0.87 is 0.942, 0.943, 9425. Okay, so this would be 0.943. So let's put that in. All right. Is that it? Yep, looks like that's it. Okay, any questions? I know some of these gets a little complicated, all right, but if you just, first thing to do is mark down keywords, okay? The givens, the and the ors, all right? And then, see if you can follow and write down, the numbers that's given, and see if you can, just try it out, punch it in, and see you get it right, the right answer. Okay. Now remember, as you work on homework, okay, you can always use the resource built in. Okay, if you click on Get More Help at the bottom, okay, you can look at textbook. All right. For these homeworks, you probably don't need StatCrunch much. And you may always send me a question by clicking on Ask My Instructor. Okay, and then of course you may view an example, see how they work out a problem like this one. Okay, now help me solve this. It actually breaks down the problem into multiple steps. So, uh, and I would say that for problems like these, it may actually be very useful because it'll break down the steps for you. Okay, so if you're having issues, try some of these resources and see if it helps you out. Okay, all right. So that's all I got. Any last minute final comments or questions about anything? I'm keeping one eye on the chat box. You may use the chat box to ask a question or, okay, oh, you're welcome. Okay, all right. Thanks. Thank you. Appreciate it. Have a good night, Marisol, Whitney. Okay, and I will see you guys next Monday. The test should be the test score should be graded by Monday. All right, so have a good night.